Hello, good afternoon, good day to you wherever you are watching me from. And I would encourage you to share, like, and subscribe to this channel where we share various research related videos. And today we will be speaking to the validity and reliability in research as far as instrument is concerned. So these two foundational concepts determine whether a research instrument is truly measures what it's supposed to measure, and does the instrument do that consistently. So this is the very essence of these particular two concepts. Is it doing it consistently? You know, when you have a knife that is very sharp and the sharpness became bluntness, what you do is to sharpen it so that it will consistently cut. So you are making the knife reliable. Now, the essence of doing this is very important in research, because without the validity, the instrument is used to collect data, and these data are further processed to come into conclusion concerning variables. So the first thing we must know is the definition of validity, and it is simply the extent to which an instrument measure what it is supposed to measure. It is generally measures in degree, and hardly could you have an instrument that is 100% valid. Validation involves collecting and analyzing data through pilot testing. For example, when we want to measure pay satisfaction, and we are looking at it as a dimension of overall job satisfaction, what we must measure is the overall job satisfaction, because the pay satisfaction captures only one dimension of a multi-dimensional construct. Let's give an example of depression. If we have depression as a construct, the subconstruct under it, we have sadness. We may have other things around depression. We may have sadness. We may have sleep problems. We may have fatigue. We may have hopelessness. So when we want to actually determine whether something is valid, we want to see whether it measures what it's supposed to measure, or part of it, or is measuring part of it. For instance, we have three types of validity. The first one is the content-related validity, which we could also call face validity in some instance. You see, in this type of validity, you design the instrument. It might be a questionnaire, it might be an achievement test. The expert judges and you give it to an expert. It's a human-based validation, whether the item cover the content area and are appropriate for the user. Let's assume you are talking about parental support and you have items measuring parental support. The expert who is a researcher in that area will know the indicators of parental support, because many of the things we measure in behavioral sciences, They are latent. They are not something that is concrete that we can take. But there are some things we used to observe. So it is the relation, it is those observed. For instance, if we say depression, depression cannot be really observed, like I said, but one can observe sleep problem and say, I have sleeping problem. The other person can say, I experience sadness, I experience fatigue, I experience hopelessness. Those are the things that could be observed. So when we sum all of them together, we will now know whether that instrument will totally measure sadness and depression. You know, the same thing with every construct. It might even be an achievement test. If an achievement test is having the is supposed to cover areas of English language, all the areas that the student has covered in a particular level. Now, the issue is that the students, if a particular topic is left out and they have covered it, it means that instrument does not meet the content validity part of it. For instance, now, apart from the content area, even the presentation of you will notice that standard exam like IGCSE, the way they print it, the way they space it, the way it is very easy to. I know you must have been in an exam before and maybe the examiner just rushes in and say, ladies and gentlemen, I want to apologize, go to question 2. But some standard exam, the face validity has been done and that type of error can never be observed. The way it is typed, is it well spaced? Is the numbering correct? Those are the issues around face validity. The next is the criterion related validity, and this instrument score compared to current and future criteria. I will do that detailed in one other video. So another one is what we call the construct related validity, where we have its ongoing process. We want to check whether the items discriminate or converge. We will look at those details in this video as we go on. So let us talk about the second type of validity, which I did not explain in details, which is the predictive or concurrent validity. You see, it is criterion related validity, and I said it has two. It could be predictive, it could be concurrent. So these two, they are asking whether the measures align with important outcome or standard. So the comparison can happen now or later. So let me talk about predictive. You know, when you have a scale to forecast a future criteria, for example, how well the first year GPA is predicted by admission tests. What I'm saying is that, for instance, if we have the admission score of a student, maybe in the Nigerian context, let's say it's the post-UTME score, and the GP of that student, predictive validity is telling us whether what the person scores in post-UTME actually predicts or determines the score of the person in or the first year CGPA, whether they are going to be related, whether it's going to predict it. This type of predictive validity is for future usefulness. So if they are predicting very well, that means that post TME score is valid. Now another one is concurrent validity, whereby it is often used when a new measure is compared with established or goals. For example, a new depression questionnaire may be compared with a clinician interview. A new science test may be compared with a well established version. So what it means is that you see that one is validating what will happen in the future, while the other is validating what is happening now. We already have a standard instrument to measure intelligence quotient, widely known. So somebody now develops another one, and the same student was given the two. We now classify the first student, one of the students, as having a high intellectual quotient, while by the standard instrument, and the other one classify the person as low. So it means that the new designed instrument does not have a concurrent validity with the established one. That is the logic of the validity, as it were. So the key difference is that one is useful for the future, the other one is about the present agreement. But both help us have the real world value beyond just looking at statistical reliability. I will later talk about the other one, that is discriminant and agreement. Now let us talk about reliability. Reliability is how consistent a measure is. So a reliable tool gives similar results under the same or very similar condition. It's very reliable. The reason we need to be consistent is to be able to trust the instrument and use it for decision making. So without reliability, results may reflect random error instead of real traits or condition. Common type include test-retest reliability. That means when we give this test, we design a test, a questionnaire, a skill, anything, give it to this person the first time, and we give it to the person the second time. The score they have in both areas agree. The another one is inter-rater reliability. Let us assume we have a skill that we want to be using to measure the food taste. We give it to, is this sweet? And we have some items. Is this, maybe we want to taste cake, and we have some item, maybe the people that are bakers who are experienced, we develop the skill for them, and two of them ate the same piece of cake and they checked the same results, and when we looked at the two results, they are the same. So it means for them to be the same, it is reliable. That instrument we develop is reliable. Now we have internal consistency, item measuring the same context and all of that. Now, Reliability means a measure is consistent. Validity means it is accurate. And I want you to get the difference. It might be valid and not reliable, and it might be reliable and not accurate. It might be reliable. So, reliable does not automatically mean valid, but validity requires reliability first. So, in short, reliability is the foundation for measurement. To explain that very well, I would love to come here. An instrument may be reliable without being valid. Look at it. For example, if we have a bathroom scale, that scale usually adds 5 kilogram to the person's actual weight when it's measuring. It will add 5 kilogram in error. So if you are 60, you will get 65 kilogram as your result. And it does it accurately it does it consistently anytime it measures anybody. If somebody is 80, the person will see 85. If somebody is 70, the person will get 75. That particular scale is reliable but not valid, because the result is giving us is not the actual weight of the people climbing it. So giving the same result repeatedly is reliability, but giving the accurate result is validity. So the scale that is adding 5 kilogram is consistently wrong, but it is not valid. So an instrument must first produce a consistent result. Only then can it accurately measure the variable. Inconsistent results cannot be valid. So reliable measurements are foundation for validity. So I quickly looked at 5 reliability estimators in this section. So the first one is inter-rater, where 2 raters or observer give a consistent answer or estimate. You know, they may look at a rating and they say, oh, the painting of this wall, maybe we have smoothness, and we rate smoothness of the painting 5 to 10 using correct color, finish, shining. We have those things. And Mr. A, an experienced rater, score the person 5, 4, 3, 2, and the other one also score 5, 4, 3, 2, or there is just a little difference. So the reliability estimators for those kind of instruments is inter-rater. So we can also have another one, which is test-retest reliability. In education research, let's say the students are writing a comprehension passage on a particular topic, and we have a method of scoring them, and we want to be sure that that thing is correct. This type of one, we use test-retest reliability. You know, also we have parallel form reliability, whereby uh, 2 tests are constructed the same way from the same content, and they are administered to the same people, 2 that are like almost the same, and check whether they agree. So we have another one, internal consistency of results across items. We can use Cronbach Alpha, which is, we can use KR20 for most of the objective items in education that test knowledge. KR20 is suitable because the assumption of KR20 is that the instruments items have unequal difficulty, while KR21 assumes that the difficulty are equal. We also have another method which is called the split halves, and the score is correlated. Let's say I have 10 items measuring cleanliness, and I can split it into 5, and I would administer it to a group of students. And there is a analytical tool called Spearman-Brown coefficient, which we will use to determine whether the instruments are agreeing, are reliable, the consistency of the score. Now, immediately we start any study and we develop the instruments, the first thing to do is to carry out face validity. That means there are experts in that area. They may correct it. They may say, oh, you are measuring anger, but some things are not, some things are indicator of anger. Why don't you add them to it? How did you type it? Maybe some items have double barrel questions and they are not good enough in that form. What you will now do is to ensure that the items are agreeing with one another. That is very important when it comes to face validity. So it is most of the time subjective judgment of experts, colleagues. Sometimes you can use it even on respondents and see. It is the weakest form of validity, but important for building respondent confidence. You know, after that, we can now go to do a pilot administration. You can see the arrow coming. The arrow started from, so from face validity, we now do, when we have done all the corrections, we now do a pilot administration, whereby we administer the instruments to sample of the population that we are not targeting for the main study. You know, when we administer the instruments, we will now carry on the other types of validity, which we have mentioned earlier. Permit me to go back. You know, you start with, this is the face validity. So you may want to do criterion or construct after you have done that. So you know, and you can see here, for example, if you do internal consistency or split half, it will tell you some items that are not good, some items that are to be revised. So after you have done pilot testing, administering it to a small sample that will not be part of your real sample, but uh, they are they are in the population similar to the population that you want to administer the test. You can now do an item review. You revise the weak items, and you, after you do the item review and revise the weak items, you can do face validity again. And in the pilot testing, you will know the weaknesses, the ambiguities, the problem, and the values. Then you will now do the main study after you have cleaned it up to make it better. I would love to mention the type of validity that is also available in qualitative research. We don't do the numerical value reliability more often. Rather, we refer to trustworthiness. That means the confidence in truth of the findings, the transferability to other contexts, the dependability, that's consistency of the finding over time, and the confirmability. These are the things that is actually uh, not mentioned in qualitative research, which is very deep, which we can't complete in this video. Now, when we want to do the types of validity, the type of validity that has to do with skill development, those people in human, like counseling, psychology, that develop skill, for their own validity, they may need to do something called exploratory factor analysis, and another one that is called the confirmatory factor analysis. So, I have said it that there is something called latent variable and there is something called observed variable. Latent variable is like, let's say we want to talk about depression. It's latent. We can't measure it directly. But the observed variable are things like sadness, sleep problem, and so on, that we can say, somebody can say he agrees he's sad, he's always having sleep problem. All those ones will now add up to be depression. So the exploratory factor analysis allows the researcher to know which item can, how many latent factors can actually be identified to measure depression, apart from the ones that is poor, that is already known. The second thing is that the exploratory factor analysis now say which of the variables, actually belong together. I said some of the variable, for example, like sadness is latent. It might have items that we will use to measure sadness. The equation, let me give you an equation now, assuming that sadness plus sleep problem equals to depression. Even sadness is latent. So for us to measure sadness, we need some items that we can easily observe. So what are those sub variables? How many of them exist? How many of them come together? How many of them have hidden dimensions? That's what exploratory factor analysis will do. While the confirmatory factor analysis does is that it tells us the load of each of the latent factor on which each of the latent factor. What is the load? The factor load of sadness to depression. In the observed variable, what I mean is that, sadness is like a observed now. So what is it loading to depression? What is its percentage contribution to depression? And it will also show us whether the model fits to the depression. So we will be able to refine and do other things. So from this video, we have learned a great deal on reliability, types of reliability, validity, and so much more. I would love you to subscribe to other videos. Thank you.